Please join me in welcoming to the Distinctive Voices podium, Dr. Katharine Hayhoe.
Thank you. It's great to be here with you today. I arrived this afternoon from San Francisco, where about 25,000, yes, 25,000 Earth scientists from around the world are all gathered in San Francisco to talk about climate change and about other Earth sciences. Now, Earth science also involves seismology. So for 1 week, every year, just about every seismologist in the whole world is in San Francisco. Isn't that tempting fate? Yeah. So in San Francisco this morning, we had a panel to talk about how do we do science, how do we communicate science, how do we act on science in this new world in which we find ourselves. I don't feel quite the same as many other scientists, though, because I have been living in Texas the last 9 or 10 years. So I've already been in that world. So what I wanted to do here tonight is something a little different than what I usually do. I wanted to start by sharing my story with you, and then share a little bit more on how I have been talking about climate change already in the past 10 years, and how all of us can continue to talk about it in the future. Because the number one thing that each of us can do about climate change is talk about it. They've done studies, and studies have showed that even among those of us who are firmly convinced not just of the reality of the science, but are concerned about the seriousness of the impacts, we don't really talk about this issue. So I want to give you some ideas on how to talk about it, because often it's a little bit scary. We're not quite sure how people will react if we bring it up, but there is a way to bring this up and talk about it. And that is the number one thing we can do, because the reality is that if you look across the spectrum of everybody in the United States, there aren't that many people who really think that climate change isn't happening. When you look at the numbers, it's only about 10% of the population. Now, that 10% is very loud. That 10% is primarily concentrated in Washington, D.C. right now. But it is only about 10%. The reason why climate change didn't come up in the presidential debates, the reason why many elected officials who behind closed doors will say, sure, it's real, will say it isn't in public, the reason why we haven't progressed further than we have is not because people don't accept the science, it's because people don't care. When we ask people to rank the issues they care about, climate change comes in close to the bottom of many of our lists. The first thing we can do towards caring about this issue is talk about it. So how do you talk about it? Well, I'm Canadian originally. You can probably tell a little bit from the way I say about. Yes, it's not a boot, it's about. I'm Canadian, and before I moved to the States for graduate school, I had never met anybody who didn't drink. This is some of our Canadian beer that we are so proud of. And I had never met anybody who didn't think climate change was real. I was so unaware that this was even such a large section of the population at that time that my husband and I had been married for about 6 months before I figured out that we were on opposite ends of the fence on this one. So, however, being recently married at the time, and also being married to somebody who is very smart and very analytical and who had just finished his own PhD at the time, we started to talk about it. And we talked for weeks, we talked for months, and we even talked for over a year about this issue. We started by talking about, well, it's cold outside, where's global warming now? We started off by talking about the differences between weather and climate. Weather is like a single tree. It's what happens in a certain place at a certain time. Climate is like a forest. It's the long-term average of weather over 20 to 30 years. So when we say it's cold outside, where's global warming now? It's like saying, I'm on the Titanic and my end just went 200 feet up in the air. It can't be sinking. We need a big picture perspective when we look at climate. Just because it's cold outside one day doesn't mean that the planet isn't warming. Now, to give ourselves a little bit more credit, you might say, well, who would say that? Our bodies are actually conspiring against us. They did an experiment where they took a group of people like this and divided the group in half. Half of the people were in a room that was about room temperature, 72 degrees. The other half of the people were in a room that was above room temperature, I think somewhere around 78. And then they asked those two groups of people, do you think global warming is real? What do you think happened? Yeah, exactly what you think. Do you think that the people in the room that was warmer than room temperature actually thought to themselves, because this room is warm, I think global warming is real? No, I don't think anybody thought that. But our bodies and our minds are subconsciously affected by our environment. So when we walk outside and it's cold, we say, oh, it's so cold. So much for global warming. But the reality is that we are not looking at a single day or a single place. We're looking at the long-term average around the entire planet, or in other words, the big picture, to determine whether the planet is warming. We also talked, though, about, hey, if you look at global temperature, this is global temperature measured by thousands of thermometers around the whole world. When you look at global temperature, actually that, it kind of goes up and down a little bit, but it doesn't really look too alarming. It doesn't really look like it's going up. Well, think back 2 slides. How long of a time period do we need to really look at climate? 20 to 30 years. This is not 20 to 30 years, is it? No. When we start to look over climate timescales of 20 to 30 years, we see, no, the planet is warming. In fact, 2014 was the warmest year on record. Was because 2015 passed it as the warmest year on record. And 2016 is, according to NASA, locked in to being the subsequent hottest year on record. It isn't just a matter of thermometers, though. When we look around the world, we see evidence of a warming planet all around us, whether it's thawing permafrost in the Arctic, whether it's record heat waves. In Australia, a few years ago, just before we published our book, they had a heat wave so severe that they had to add an extra color to their temperature map. That purple in the middle is 54 degrees Celsius. I see people understand Celsius here. That's good. It's about 129 degrees Fahrenheit. We see rising sea levels causing sunny day flooding in Florida. This is not a storm, it's just a high tide. And we see all kinds of natural thermometers like the cherry blossoms in Washington, D.C. and in Japan. They've tracked them in Washington, D.C. for 100 years. They've tracked them in Kyoto, Japan for 1,100 years. They are now flowering weeks earlier than any time in that 1,100-year history. Around the world, there are over 26,500 indicators of a warming planet, some of those in our own backyards. That is how we know, when it comes to a changing climate, it is real. So once we had covered the evidence for a changing climate, and that took perhaps a few months, we then moved on to the next very important question. Isn't it just something that's caused climate to change in the past? Because we know that climate used to be different. We know that at one time there were giant ice sheets covering half of North America. We know that further back there were crocodiles at the North Pole. I have somebody at my own university who studies those crocodiles. We know that climate has been different in the past when there weren't any humans around. So before we immediately jump on the bandwagon and say, yes, this change has to be human, we have to look at the other reasons why climate has changed in the past to see if they could explain our warming. And 2 of the biggest reasons why climate has changed in the past are changes in energy from the sun, because that's where most of our energy comes from. A little tiny bit comes from the Earth's core, but the vast majority comes from the sun, and natural cycles. So let's look at these to see if they can explain the warming that we're seeing today. So here's the Earth's temperature. I don't know if you can see it. The very faint squiggly line is the year-to-year temperature, and then I put the thick line on so you could see kind of where it's going long term. Now, I'm going to test your brains here, but it's not a trick question. If the Earth's temperature were going up because of the sun, does that mean that the sun's energy would be going up over time or would be going down over time? Give me your thumbs up or thumbs down. If the sun's energy were changing and warming the Earth, would be going up or down? I see mostly thumbs up. Good. So let's just add the sun's energy here to this figure. Now this figure goes all the way back to 1850. So let's take a look. Well, we have this 11-year sunspot cycle that changes the sun's energy in regular 11-year cycles. And up until the 1950s, actually, the sun's energy was going up. Now, I changed the scale on this figure so we could actually see the changes. The actual change in the blue curve from 1900 to 1950 is not very big. It's actually quite small, but it is positive. But what's been happening since the 1960s? The sun's energy's been going down. So if our temperature were being controlled by the sun right now, we'd be getting cooler, not warmer. It can't be the sun. Could it be a natural cycle like El Nino? El Nino is one of the natural cycles we have in the Earth system. There's quite a few of them. And what these natural cycles do is they distribute heat around the Earth system. When we have an El Nino, it pulls heat out of the ocean and puts it into the atmosphere. So an El Nino year in the atmosphere tends to be warmer than average. During a La Nina, it pulls heat out of the atmosphere and puts it into the ocean. So a La Nina year tends to be a little bit cooler than average. Other natural cycles move heat back and forth from north to south or east to west, but most of them move heat back and forth from the ocean to the atmosphere and back again. Natural cycles within the Earth's climate system cannot create or destroy heat because that would violate conservation of energy. All they do is move the heat around. So, get your thumbs ready again. If our air temperature, which is what is measured by all our thermometers, if our air temperature were increasing due to a natural cycle inside the Earth's climate system like El Nino, that heat would have to be coming from somewhere, right? And the most likely candidate is the ocean. In fact, that's pretty much the only place it could be coming from. So if we looked not just at temperature, but if we looked at heat content, if the heat content of the atmosphere is going up due to a natural cycle, what do you think is happening to the heat content of the ocean? Give me a thumb. You guys are good. Yes. It should be going down. So let's look at what it's doing. Here in green, we have the change in the heat content, not just of the atmosphere, but of the land and ice all put together. And this is in exajoules. Isn't that crazy? But what's the blue line? The blue line is not going down the same amount that the green is going up as it would be if it were a natural cycle. The blue is actually going up too, and it's going up a lot more. Did you know that 93% of the extra heat that is being trapped in the Earth's climate system as a result of the extra blanket we're wrapping around this planet, that's really why it's changing. Did you know that 93% of the extra heat that's being trapped in the Earth's climate system is going to the ocean? So when we use air temperature to measure global warming, we are literally looking at the tip of the iceberg of global warming, and 93% is under the water. Now you might say, well, why don't we talk about this more? It's because we don't live in the ocean. If we were dolphins, we'd be talking about it a lot more. But it is having a huge impact. You know the coral bleaching that took place in Australia this year? It was a warmer ocean with a little bit of El Nino on top of it. We are seeing marine species moving poleward at an unprecedented rate. The ocean is changing. And the entire planet is warming, so it can't be one of these natural cycles that just move heat around. The whole planet is warming. You might say, though, but I've heard that there's a different type of natural cycle, and there is. And you will know all about this if you have children or grandchildren, because if you do, you will probably have watched this movie about 1 million times. Yes? Anybody? Yes, a few hands, yes. So we know that there was this periodic cycle that the Earth goes through where we have ice ages, and then we have warm periods, and then we have ice ages, and then we have warm periods. So here's the natural question. aren't we just still warming after the last ice age, right? Well, to answer that question, we need to look at temperature records that go back a little bit further than 1850. How do we get those temperature records? The first thermometer was actually invented in the 1650s, and it was used from 1659 onwards to measure temperature every single month. So we have a temperature record from thermometers going back to 1659. But we need something that goes back further. Where does that come from? It comes from ice cores. Ice cores are fascinating. They're about this wide, and they are incredibly long as the ice is deep. Scientists go up to Greenland to get them. They go down to the South Pole to get them. They go to tropical glaciers to get them. And in those ice cores are little bubbles of air. And in the little bubbles of air is a little tiny bit of the atmosphere at the time when that ice was formed. Now, you can't measure the temperature of the air because it's all freezing, right? Because it's in ice. But you can measure the oxygen ratios and the hydrogen ratios in those little bubbles that tell you what the temperature was when that layer was formed. You can also measure the levels of heat-trapping gases and dust, soot from volcanic eruptions and dust storms. It's really amazing. So using these types of natural thermometers, we can look at the history of human civilization on this planet. How long has it been since we developed agriculture, since we started to build cities, since we started to keep written records? It hasn't been that long. And over the course of human civilization, our climate has been remarkably stable. Remarkably stable with a very, very, very gradual trend. A warming trend? No. A cooling trend. Why? Because warming after the last ice age peaked about 8,000 years ago. And since then, you can calculate it from trigonometry, since then the changes in the Earth's orbit that alter how sun falls on the Earth, which is what drives these ice ages and warm periods, those changes in the Earth's orbit are heading us towards another ice age. Were, that is, until something happened. This difference is even more stark. So if you look, we have temperature up here, we have carbon dioxide down here, and this is where we're getting the first clue that something is different. Look at carbon dioxide, and now we're not going to go back 6,000 years. Now we're going to go back to our oldest ice core, which goes back 800,000 years. This is what the carbon dioxide looks like, and temperature tracks it very closely. This is what the carbon dioxide looks like over time. Warm period, ice age. Warm period, ice age. Warm period, ice age. Warm period, oh my goodness. We are heading into unknown territory. We are heading into carbon dioxide levels that we have never seen in the history of human civilization on this planet. And that is really the crux of the matter, because we have 7.5 billion people. And if sea level rose 3 feet, 5 feet, 8 feet, 10 feet, 10,000 years ago, who cares? If it rose 1,000 years ago and you lived in New York City, on Manhattan Island at the time, what would you do? You pick up your tent and you move it a bit. What would happen if the crops that you grew, you couldn't grow them there anymore 1,000 years ago? You just pick up and move. What happens today? You can't pick up New York City and move it. You can't say, oh, well, I can't farm what I normally farm in Texas, so I'm just going to go take over Kansas. That isn't the way the world works with 7.5 billion people, and that is why a change in climate matters to us. So when we look at the natural suspects, as I call them, it can't be the sun this time, because if it were, we'd be getting cooler, not warmer. It can't just be natural cycles like El Nino, because the whole planet is warming, not just certain parts of it. And it can't be the Earth's orbit, because the next thing on our calendar is another ice age, not more warming. Now, don't be afraid. We wouldn't be in another ice age tomorrow or the next day. But what's the ideal temperature for us? The ideal temperature for us is, go back here, we like it not too hot, not too cold, just right, like Goldilocks' porridge. So the interesting thing, this is just a little side note here, the interesting thing is, you see those carbon dioxide levels gradually, slowly going up just a little bit before the Industrial Revolution? Why were they going up? Development of agriculture and deforestation. we were on our way to stabilizing climate at just the right temperature for us until the Industrial Revolution. Isn't that interesting? So that's why when we talk about climate change, we don't just know it's real, we know it is also us. So it took my husband and I probably about a year to get to this point, because back then we didn't have Skeptical Science. Do you guys know about Skeptical Science? It is a fantastic website. It's also got an iPhone app that answers every single but what about question on climate you've ever seen. In 10 years, I have only ever caught 2 questions that they hadn't answered, and each time I emailed that question to them, and they posted an article the next week. So it's pretty impressive. We did not have Skeptical Science. That's why it took so long to figure all this stuff out, but you have it at your fingertips now, so this will only take you a few days. But now we get to a bit of a tougher question that isn't really about the science. It's a question of, why do we care? Because if you write a book about climate change and you ask somebody, what picture should I put on the cover of the book? You know what 99% of the people are going to say? A picture of a polar bear, preferably sitting on a iceberg. Exactly. You've seen the books. This is the #1 image associated with a changing climate, and it is true. Polar bears are uniquely vulnerable to climate change. But if this is the only reason that we are talking about completely revolutionizing the entire way that we get our energy around the whole world, is a single species up at the North Pole that most people never see in real life enough reason to do that? Honestly, many pragmatists would say no. But that is why when Polar Bears International asked me to go up to the Arctic with them last year to follow the polar bears out on their annual migration to the ice, and Polar Bears International is an amazing organization. They have a live bear cam during that season that you can log into anytime on your computer and watch bears. When they asked me to go with them, I said, well, I would love to go with you, but to be honest, I work primarily with people. I care about a changing climate because it is affecting people. And they said something to me that was incredibly profound. They said, the reason we care about polar bears is because they are showing us what is going to happen to us if we do not heed their warning. We care about a changing climate because it exacerbates the risks that we already face today. 99% of the time, climate change is not bringing some bizarre plague of locusts that we've never seen. Now, sometimes it does, but most of the time it doesn't. Most of the time, climate change hits us right in our Achilles heel. What is one of the biggest concerns related to climate and weather here in California? Thank you. Yes, drought. I live in Texas, and it's drought there too. Is drought a natural part of life in California? Yes, it absolutely is. If we go back in the paleoclimate records looking at tree rings, we know that there have been big droughts in the past, droughts so big they call them mega droughts. But we know that we are in a remarkable situation today where you see headlines like this almost every time you pull up your browser or open the newspaper. I was just at a talk yesterday where they were talking about the ridiculously resilient ridge and how this weather phenomena of high pressure directs storm systems up and away from California, enhancing the drought. Is this ridge a natural phenomenon? Yes. But what we're finding is warming is exacerbating the risk of having this type of a ridge. It's taking a natural phenomena and it is changing its frequency and its intensity, which prolongs the drought. Without climate change, would there have been a drought in California the last few years? Initially, I would guess, yes, that there probably would have been. Without climate change, would that drought have been as strong and as long as it has been? No, I don't think it would have been. Climate change takes a natural risk and it exacerbates it. What other things are we vulnerable to as humans in our human society? We're vulnerable to water shortages. Half of California's water comes from snowpack. What happens as it gets warmer? In the winter, more precipitation falls as rain and less as snow. So one of the biggest impacts of a changing climate, actually, go back here, one of the biggest impacts of a changing climate on California is to massively reduce the natural reservoir of water that melts at just the right time of the year to feed the Central Valley. In our groundbreaking study in 2004, where for the first time we showed the difference between a fossil fuel intensive scenario versus a low emission scenario for the state of California and its impact on California's water and agriculture and health, we showed that California stands to lose up to 90% of its snowpack reservoir if we continue on our current pathway of depending on fossil fuels as our primary source of energy. And that single result was so impactful that it was actually quoted in the governor's executive summary, or executive action, I should say, making California the first state in the entire country to have mandatory greenhouse gas emission reduction targets. That's how important this is for California. But it isn't just California. Around the world, 1 billion out of the 7.5 billion people on this planet, 1 billion depend on water from glaciers. And right now they have more water than they can deal with because the glaciers are melting so quickly. But once those glaciers are gone, what's left? Nothing. This is the glacier, one of the glaciers that supplies the city of Lima, Peru. 8 million people and a few inches of rain a year. People have used this glacier for so long that some of its water flows through irrigation channels built by the Incas. But this glacier is melting back so quickly that they had to install desalination plants, and desalination plants cost a lot more than free water from a glacier. What other ways are we vulnerable to a changing climate? Remember that map of Australia? What was that map of? It was of a heat wave. In Europe in 2003, 13 years ago, they had a heat wave so severe, it killed 70,000 people. That is not a typo. That is not a mistake. You heard it right. 70,000 people. The risk of that heat wave, scientists determined, had doubled as a result of a changing climate. So it's like you take a pair of dice. There's always a chance of rolling a double six. That's your natural heat wave. What climate change is doing is it's sneaking in when we're not looking, and it's one by one taking those other numbers and replacing them with more and more sixes. So the chances of rolling that double six go up and up and up. It's not just happening here in the United States. It's not just happening in Europe. It's happening around the world. Last summer, there was a heat wave in India. People there do not have air conditioning. They do not have public heat warning systems. They do not have cooling centers they can go to. And thousands of people died. What are some other ways that we're vulnerable already to climate and weather? The biggest damages come from drought. Where do the second biggest damages come from? What's the opposite of drought? Flood, exactly. Is flood normal and natural? Yes, it is. But what's been happening? Over the last 50 or 60 years, the risk of heavy precipitation has significantly increased, especially up in the Northeast and the Midwest. This is the observed increase since the 1950s. Now, heavy precipitation does not always translate into flood, but it does if it's falling on saturated ground, and it particularly does if it's falling on what? Impervious surfaces. Huge flooding in Houston this past year. In Houston, the risk of heavy precipitation has increased significantly because Houston is right there on the Gulf of Mexico. And as the ocean warms, water evaporates faster. So there's more water vapor sitting up there in the atmosphere today than there was 50 or 100 years ago. And along comes a normal storm, just as it would any day, but there's so much more water sitting up there for that storm to pick up and dump on us that's why we're seeing these increases. If you follow the news during Houston flooding, during the Baton Rouge flooding, you remember that? The Baton Rouge flooding? You will see meteorologists saying there is a near infinite source of moisture for this storm because why? 2016 was the warmest year on record. Ocean temperatures were the highest ever recorded. That water was evaporating faster than you could track it, and that storm was just picking it up and dumping it. what does flood look like? This is a 6-lane freeway in Lubbock, Texas, beside our football stadium. Those are the undergraduates floating away. We flood regularly. We flood for 2 reasons. For 3 reasons, actually. Number 1 is we have a pattern of heavy precipitation, flood, and drought in Texas. Number 2, we've paved a ton of area, and this is a very poor example of how not to build a highway. But number 3, what? Let's go back here. What is the 3rd reason? Climate change is exacerbating the risk because the warmer it is, the more water evaporates. There's more water vapor sitting up there in the atmosphere for any given storm to pick up and dump. It isn't just happening in the United States, it is happening all around the world. And then we have the hurricanes. We haven't even gotten to them yet. Now, if you watch the Weather Channel, if there's any weather geeks here, you watch the Weather Channel whenever there's a hurricane, you will hear, and you probably have heard, the forecasters saying something like, and this is Rita, by the way, if anybody's wondering, we have a category 2, but you see that pool of warm ocean temperatures there. If it goes over that pool, it will ratchet up to a 3 or 4, maybe 5 before it hits land. Why? Because hurricanes get their energy from warm ocean water. This past year, the warmest year on record, with the warmest sea surface temperatures ever recorded, we saw storms go from a tropical storm to a category 5 hurricane in 36 hours. Why? Because they passed over the warmest ocean temperatures ever recorded. What do we expect to happen in the future? In the future, we do not expect any more hurricanes. In fact, there actually may be less hurricanes as the temperature difference between the poles and the mid-latitudes flattens out because the poles are warming a lot faster. So the atmosphere might be a bit more stable. We might actually see less hurricanes. But when we get the hurricanes, watch out. We have already had our first category 6 hurricane. We've had it already. And pretty soon, we're going to see more of them. Hurricanes are getting stronger because they're fed by warm ocean water. And not only that, there's more precipitation associated with any given hurricane. Why? Because of the faster evaporation in a warmer world. What does that mean? Well, it means, together with sea level rise, right? So you have stronger hurricanes, you have more rain, and you have sea level rise, we're seeing more flooding. And we aren't just seeing it in Texas with Patricia, but we're also seeing it in other places around the world where they don't have the National Guard, they don't have flood insurance, and they don't have clean sources of drinking water. So when Hurricane Matthew, do you remember that? Hurricane Matthew came through. It hit Haiti, and then it hit the United States. It hit both at about the same strength. The impact was radically different. More people in Haiti died of cholera from contaminated drinking water than from the direct impacts of the hurricane. We are vulnerable in so many ways, and the people who are poor and disadvantaged already are the people who are most vulnerable to the impacts of a changing climate. And then there's the climate refugees. Native American villages in Alaska, 200 of them that are at imminent risk from thawing and crumbling permafrost. Who says they're at imminent risk? Is that a quote from Greenpeace.org? No, it's a quote from the U.S. Army Corps of Engineers. Not exactly a reactionary group. They're not the only climate refugees. This is another Native American tribe who live down on the coast in Louisiana. Their land is sinking into the ocean and they have to move too. And there's many islands in the South Pacific where already during storms, their islands are almost completely overtopped. They're trying to immigrate, but New Zealand is only taking 75 people a year. When we look at a map of where our carbon emissions come from, over the last 100 years, if we add up all our carbon emissions, this is where they come from. And then we look at a map of who and where is most vulnerable to a changing climate. Fix this map in your head for just a minute. Ready? Here's the map of who's most vulnerable. So when we talk about climate change, it isn't just that it's real, it isn't just that it's us, it is serious and it is not fair. So after talking about this for days, months, even a year with my husband, we ended up like this. And we wrote a book together. And the book, we have a couple of the first editions still left, and they're going to be raffled off at the end of the night because we're putting out a second edition that is updated, and that's my Christmas to-do job. I don't know if you do stuff over Christmas, but that's like when I actually get stuff done. So over Christmas, we're going to be putting out the next edition, which you'll be able to get on Amazon. But there are a couple of copies of the first edition left, and we wrote this book together. But then I started to look around at my fellow scientists and at many other of us who want to talk about climate change. And just about every single time we talk about climate change, Susie the scientist pulls out all the scientific reports. This is literally a picture of every Intergovernmental Panel on Climate Change report that's been published so far. If you stack them up, they would reach above the screen, if you include the special reports. How does Calvin respond when Susie the scientist pulls out all her facts and data? With identity, feeling like it is, and who Calvin is being threatened. Starting with the science, social science has shown, deepens the trench between us. And typically leads to something like this. Why is that? We live in a society where this is what we look like 22 years ago. Republicans, Democrats, the average was actually pretty close together. The distribution was nice and smooth, what we call Gaussian. Fast forward to 2011, and then 2014. What has happened in the United States over the last 22 years? Two things. The average has moved farther apart, and look at those colored areas again. See that? People are moving out to the edges. We are so polarized right now that this is crazy. The number one predictor of who someone will marry in the United States today, if they're not already married, is not level of attractiveness, not personality, not race, not socioeconomic status, not level of education. The number one predictor of who we will marry is where we fall on the political spectrum. I didn't read that study before I got married. And I think it's a good thing I didn't. So what does this have to do with climate change? Well, last year, they asked people what they thought of certain issues, and then they divided their answers up into what answers were very different, depending on people, if people were Republican and Democrat, versus what were very similar. So the number one issue last year that people were most polarized on, depending on their political party, was, do you approve of the president? And honestly, that should be the number one issue because that's the whole point, isn't it? Right? Now, here's where it gets really depressing. Let me show you the rest of the issues in order. So they're going to be in order of which ones are most politically polarized. Ready? Now, what do you think is going to be on this list? You think abortion is probably going to be on the list, right? Gun control? Immigration? The number two issue was climate change. Then you have gun control. And then, what is that? Where is, do you trust your accountant? Do you trust your physician? Do you trust your neighbor? Why is do you trust scientists on this list? Climate change has become one of the most politically polarized topics in the entire country. So how on earth can we talk about climate change in this type of environment? I'm going to share with you what I have learned. And I'm going to tip my hand right away. This is not a mystery novel with a secret ending. Number one, don't start with the science. Number two, don't end with the science either. Start by connecting with the person or the people that we're talking to. What value, what bond, what interest do we genuinely share? Then, given that shared value, let me share with you from my heart why I am concerned about climate. And then, inspire. How can we tangibly, practically, realistically work together to fix this problem? Because the social science has showed that if we tell people about a problem, but we don't offer a practical, viable, attractive, inspirational solution to that problem, what do we as humans do? Our brains betray us again. We reject the reality of that problem if we feel like we can't fix it. Because who wants to feel guilty all the time? So, how do you bond? What values do we share? I'm just going to give you a little précis of mine. Think about what yours would be. Are you a fisher, man or woman? Do you enjoy skiing? Do you have kids or grandchildren? Do you belong to the Rotary Club? I gave a presentation once to our local Rotary Club, and I'm not a Rotarian myself, but going in, I saw their banner, and I thought, oh my goodness. Is climate change the truth? Yes. Is it fair? No. Would it build goodwill to do something about it? Yes. And will it be beneficial to all concerned? Taking action would be. So I had a bit of time, so I rearranged my presentation around these 4 questions. And I gave this presentation to a bunch of conservative business people from West Texas. And I could tell standing up there, when I first looked over the faces, there weren't a lot of smiling faces. There were a lot of faces kind of looking like, should I eat the bread roll or should I save it for something else? But at the end, you could see the faces start to change. And at the end, a man came up to me and said, you know, I wasn't sure about this whole climate change thing, but it passed the 4-way test. What is one of the biggest ways we can connect with people? Over 70% of people in the United States and over 85% around the world belong to a specific church or faith tradition. And did you know that every single major faith tradition, Christian, Jewish, Buddhist, Muslim, Hindu, has as a tenet of their faith stewardship or care for creation and taking care of those less fortunate than us? Those are the values you need to care about climate change. And then lastly, there's just the simple value of the place where we live. This is our home. We want it to be a safe and secure place for all of us. I believe that just about every human on the planet already has the values we need to care about climate change. So then, how do we connect the dots? Well, we can talk about how we care about our kids' health. And I love the organizations, the Moms Clean Air Force and Climate Parents, because they connect the dots between our kids' health and air pollution and climate change. We can evoke experiences that are important to us, like not having enough snow to do what we want to do. We can highlight the impacts of climate change on our health. And what I love is the American Medical Association is even getting on board with this. We can talk about how climate change is a threat multiplier. Who says that? The Department of Defense says that. Who knew that they take this seriously? We can bring in the economy. Michael Bloomberg and Hank Paulson wrote a report called Risky Business. If you Google it, you tend to get a picture of Tom Cruise in his underwear. But their report is this one, and it talks about the risks to the economy. We can make it local by talking about the impacts that we are seeing and experiencing in the place where we live. And we can absolutely connect it to our faith. The Pope has amazing stuff that he said about climate change. And guess what? This report is by the National Association of Evangelicals on how caring about climate change is caring for the poor. So there is a lot that we can do to connect the dots, but we have to end with solutions. That is so important. What type of solutions can we agree on? Number one, talk about this. And what can we say? We can agree that we are all at risk today and tomorrow, where we live in Texas or if we live in Bangladesh. We can agree that it makes sense to prepare for a changing future. Instead of spraying water over our crops where most of it gets lost through evaporation, new techniques that put the water directly into our soil and save water in a warmer climate. In the Netherlands, where they're at risk from sea level rise, they're building floating villages. What if sea level goes up 3 feet? You buy 3 more feet of anchor chain. Who wouldn't like that? We can often agree that investing in the new clean energy economy is good too, whether you live in Texas, where turbines are replacing our oil rigs, or whether you live in Africa, where rather than putting in a power grid, they're just putting a solar panel on the thatched roof hut. Here's the crazy thing. When you look across the entire United States, and you can look this up online, the Yale Climate Opinion Maps, and you ask people, do you think global warming is mostly caused by humans? All the blue colors are less than 50%. So you look at this and you might say, We need more science. We need to tell people more about the science. But you know what? Here's the crazy thing. Even if we can't agree on the politics, which I don't think we ever will because as long as there's been humans, they've never agreed about politics. But even if we can't agree on the science, we can agree on the solutions because the same group of people who asked this question, they also asked a different question. They said, do you think, okay, get this, do you think we should regulate carbon dioxide as a pollutant? Now, if you don't think that it's causing climate change, why would you regulate it as a pollutant? I don't know and I don't care because everybody thinks we should. Do you think we should support research into renewable energy? Yes, we should too. Don't you think it's amazing that this little town in Texas called Georgetown has gone 100% green to save money? Don't you think it's incredible that Fort Hood, the biggest military installation in the US, just signed a new electricity contract for wind and solar because they saved taxpayers $168 million? Don't you think it's amazing that Texas already makes 15% of its energy from wind, 40% on a windy day? Don't you think it's incredible that they're putting in solar bike paths in the Netherlands? These are the types of solutions that we can all get excited about. Don't you think it's amazing that this little church in Minnesota offered their roof to their community as a solar garden? Or that Houghton College, a little evangelical college in upstate New York with 1,200 students, put in the biggest solar panel array of any educational institution in New York. And that includes Stony Brook, Cornell, all of those. So how do we talk about climate? We can talk about climate by bonding over genuinely shared values, by connecting them to climate from the heart, and by finding ways that we can work together to act. And that's why one of my favorite organizations is Climate Caretakers. It's this online community that every month sends you an email with a list of 3 things that you can do. If you've already done number 1, you do number 2. If you've done number 2, you do number 3. Because working together, we can make a difference. As my favorite scientist, Jane Goodall, says, it's only when our clever brain and our human heart work together in harmony that we can achieve our full potential.